Hey everybody, we are going to look at a pulley problem, a free body diagram problem involving pulleys. So our problem says that a mechanic is attempting to lift a 441 Newton engine off the floor. She has a pulley with a rope around it in the ceiling to help her do this efficiently. On the right side of the rope, she ties a 539 Newton object, which she then lets drop. What was the acceleration? With what acceleration does the engine rise? So if you can imagine this pulley system, imagine a pulley and a rope running through it, and then masses attached to both ends of the rope. And so we're told that one of those is a 441 Newton engine and the other one is a 539 Newton object. So to draw a free body diagram for this type of problem, we actually need to draw two free body diagrams. So we'll start with two boxes representing our two objects. And for both of those, they each have two forces acting on them. There's the tension force and gravitational force. Now we're going to assume that the tension force on both sides of the system is the same, and that's not always going to be the case for physics problems involving pulleys and tension forces. But in our case, we're going to assume that tension force is the same for both on both sides of the pulley. Gravity, force of gravity will be different though. So we're going to call this FGL for the left object. And then over here, we will put FGR. And then we'll put also a tension force here. And again, because we are assuming tension is equal for both, that's just going to be F sub T. All right, now in terms of acceleration, one of these is going to move down and the other one is going to move up. So we have to look at their masses or their weights. And we're told that the engine on the left is 441 newtons. And we're told that the object on the right is 539 newtons. Now, as you can imagine, the more massive or the heavier object is going to be pulled on more by gravity. And so it's going to fall, causing the other one to rise. So we look for the one that has more mass or more weight. And that will tell us which way that these objects are accelerating. So in this particular case, the object on the right has more weight, and so it is going to move downward. So acceleration on this side is going to be down. And then that means on the other side, since it's being pulled on, acceleration will be in the opposite direction. It'll be up over here. All right, so now at this point, I am ready to start plugging stuff into my equations. So as always, we are just using Newton's second law. So the sum of forces along the y-axis for the left object is going to be equal to the forces that make up its net force. So that's going to be the tension force plus a negative gravitational force. Because again, acceleration is dictating which way is positive, which way is negative. So in this case, up is positive for this side. So that is going to be equal to the mass of the object on the left, times its acceleration. And again, since we're assuming equal tension on both sides, we're also assuming equal acceleration on both sides. Now for the other one, same idea. Sum of forces in the y for the right object equals, now in this case, down is positive for this side, so up is negative. So that's going to be a negative tension force plus gravitational force, and that is going to be equal to the mass of the right object times the acceleration that this system is experiencing. All right, so now we can start substituting values. So I don't know tension. That's one of my unknowns. And so I'm going to leave that as F sub T. But I do know gravitational force, and I'm going to put negative 441. And that is equal to the mass of this object times its unknown acceleration. I'm going to cheat a little bit. I'm going to put a quick equation in here. So to get mass, I know the weight, that's the force of gravity. I just need to divide that by gravitational acceleration. So 441 over 9.8. That is my mass. This is equivalent to the object's mass. And then multiplied by that unknown A. And then I'll do the same thing over here. That is going to be equal to that unknown tension force. Don't forget the negative. plus gravitational force. And I'm going to do the same thing over here. I'm going to put that gravitational force, or its weight, over 9.8, because I need the mass here, multiplied by that unknown acceleration. So I'm going to do some rearranging so that I can get the unknowns and their coefficients on one side and any constants on the other side. It'll make setting up my matrices a little bit easier. So I'm going to say, well, the sum of forces in the y direction for the left mass, that's equal to F sub t. And so I'm going to end up swapping this over to this side and this over to this side. So over here, I'm going to put a minus, and 441 over 9.8 is 45. So minus 45, and that's multiplied by that a. And then that's going to be equal to a positive 441. So again, I just took this, simplified it into 45 and moved it over so it becomes negative, and then this I had to add to both sides, and so it becomes positive over here. And I'm going to do the same thing to the other equation, so just simply rearranging it a little bit for coefficients on and unknowns on one side and constants on the other, and I end up with negative F sub t minus 55a, and that is equal to negative 539. All right, so this is going to make setting up my matrices a little bit easier. So just like in previous problem types, I'm setting up a 2x2 matrix for matrix A and a 2x1 for matrix B. So I'm going to set this up so that my unknowns are my column headers. So I don't know tension force and I don't know acceleration. So those are my two columns. And then the equations I'm pulling their coefficients from, well, that's just F sub y sub L and F sub y sub R. And that tells me where they're coming from. So looking for tension forces coefficient from my left equation, I'm going to go up here and look. Well, that's just going to be a 1. And that's pretty much it for that one. And then for acceleration, that's a negative 45. So I'm going to put negative 45, 45 there. And then same thing from the other side. Don't forget that that is negative F sub t, so that's going to be a negative 1 coefficient, and then negative 55 for that coefficient for acceleration. And then for my constants, because I've already rearranged the formulas, it makes it much easier. For my constants, it's going to be 441 for sum of F sub y sub L, so right here, and then negative 539 for the other one. Now once I plug these matrices into my calculator as matrix A and matrix B, I want to run the operation, the inverse of matrix A multiplied by matrix B, and that is going to produce a matrix of 485.1 on the top value and 0.98 for the bottom value. And again, the labeling of your problems is super important. The labeling of your matrices in your problem is super important because the upper value in this matrix corresponds to this unknown, and the lower value of this matrix corresponds to this unknown. So our answer for this problem, F sub t, that tension force, is equal to 485.1 or 485 newtons, we'll leave it as that, and an acceleration of 0.98 meters per second squared. If you're still having problems with these problems, please talk to your teacher. Thanks for watching. Have a good one.